Welcome back to Math 104. For the experiment of selecting a family with 3 children and asking about the birth order, the event, at least 2 of the children are girls, is described by the following set: BGG, GBG, GGB, and GGG. In other words, it contains these 3 outcomes in which exactly 2 are girls. It also contains this one outcome in which all 3 children are girls. Each of these 4 outcomes contributes to the event, at least 2 of the children are girls. Notice that the phrase at least 2 means 2 or more. We will often use the phrase at least in this course, and it's important to know the difference between at least 2 and more than 2. More than 2 would be the event consisting of just GGG. More than 2 would mean strictly more than 2. Does a single outcome count as an event? Yes! In fact, it is called a simple event. For example, the event that all 3 children are boys, that's an event. It is a set of outcomes, and it has only one outcome in it. We can ask what else counts as an event that you might not have thought of. The sample space itself counts as an event. It's usually denoted by the letter S, but the sample space is a set of outcomes, namely all possible outcomes. But it is a set of outcomes, and therefore it does count as an event. You can describe it in words as the event that something happens when we perform the experiment. Another event we need to work with, that you really might not have thought of, is the event with no outcomes in it. This is the empty event. This is written either with empty braces, not enclosing any outcomes at all, or with this symbol, the null set symbol. This is a 0 with a diagonal line through it. Right now, it may be hard to see why the set with no outcomes in it would be useful to talk about as an event, because it seems to be the event that nothing happens, and it's impossible that nothing happens when the experiment is performed. Yes, that's exactly right. It is impossible that nothing happens when the experiment is performed. And we will see that the probability of this strange event is 0. So where do we stand? So far we've put together some terminology: experiment, outcome, event, sample space. Now we need one more piece of terminology before officially pinning down our definition of probability. That new term is relative frequency. If an experiment is repeated a number of times, we can talk about what fraction of the time a certain outcome occurs. We define the relative frequency of a specific outcome to be the fraction of the experiments that we actually perform in which that outcome occurs. So in other words, the number of times the outcome occurs divided by the number of times the experiment is actually performed. This is precisely what we computed in our coin flipping experiment earlier. Earlier, when we performed our first 10 flips of the coin, we obtained 4 heads. As of that moment, the relative frequency of heads was 4 out of 10. 4/10 of our flips had resulted in heads. That's a 0.4 relative frequency. But we kept flipping after that. And after we had performed a total of 80 flips, and we had obtained a total of 38 heads, as of that moment, the relative frequency of heads was now 38 out of 80, or 0.475. So this relative frequency changed over time. As we repeated the experiment of flipping more times, we collected more data, and the fraction of the time that heads was occurring changed. The crucial idea in this subject is that if we keep repeating the experiment, there is one number that this relative frequency will eventually get closer and closer to, even if eventually happens to take a long time. And now, finally, we arrive at our official definition of probability. The probability of an outcome is defined to be the long-term relative frequency with which that outcome occurs, as the experiment is repeated indefinitely. So we need the notion of relative frequency to make this definition, but we have to think in terms of long-term relative frequency. We have to think in terms of repeating the experiment in principle forever. That was the definition of the probability of an outcome. What about events rather than outcomes? It's the same thinking. If an experiment is repeated a number of times, the relative frequency of an event equals the fraction of the experiments in which that event occurs. So it's the number of times that event occurs divided by the number of times you perform the experiment. We often use a capital letter to denote an event, such as E. The probability of the event E is defined to be the long-term relative frequency with which E occurs as the experiment is repeated indefinitely. So probability of an event is defined in the same way as probability of an outcome. As for notation, we use the symbol P of E to denote the probability of the event E. The reason for this notation is that P is a function. It inputs events and it outputs numbers, namely probabilities of events. Before going on to the next video, please answer the following questions. What is the least possible probability which an event could have? And what is the greatest possible probability which an event could have? Please explain your answer in terms of the expression for the relative frequency of an event. That is, number of times the event occurs divided by number of times the experiment is performed. The answers to these questions are related to this definition of relative frequency.